In problems 1 and 2, a variable is eliminated because the sum or difference of its coefficients is 0. From the multiplication property of equality, you know that you can multiply each side of an equation to get a new equation that is equivalent to the original. That is, a plus b equals c is equivalent to d times the quantity a plus b equals d times c, or d times a plus d times b equals d times c. Using the multiplication property of equality to solve a system of equations. First step, multiply one or both equations by a constant so that the coefficients of one variable are the same or opposites. Then eliminate that variable by adding or subtracting the equations. This brings us to problem 3, solving a system by multiplying one equation. What is the solution of the system? Use elimination. Our first equation, negative 2x plus 15y equals negative 32. Our second equation, 7x minus 5y equals 17. Notice our x's don't have the same coefficient or opposite coefficients, so neither adding nor subtracting the second equation from the first will eliminate the x's. Same thing for the y's. If we add or subtract the second equation from the first, we're not going to eliminate the y's. So we have to use what we just learned about multiplying in systems of equations. First, consider what you know. A system of equations that can't quickly be solved by graphing or substitution. What you need, the solution of the system. So your plan, multiply one or both equations by a constant so that the coefficients of one variable are the same or opposites. Then eliminate the variable. Step 1. To eliminate one variable, you can multiply the second equation, 7x minus 5y equals 17, by 3 and then add. So take note, what that's going to do for us is it will leave us with negative 15y's, the opposite number of y's that we have in the original equation. So once we establish this new equivalent equation, we can add it to the first equation to cancel out y's. We'll see that begin in step 1. Negative 2x plus 15y equals negative 32, simply rewriting our first equation. Our second equation, 7x minus 5y equals 17, multiplied by 3 as we shift to the right. An equivalent equation is 21x minus 15y equals 51. Be really careful when you multiply by 3 that you multiply every term, both sides of the equal sign, by 3. Students will often forget to multiply the constant on the far right by whatever the factor is that they're multiplying by. Then we'll add the equations. Notice now we have opposite numbers of y's, so adding the equations will eliminate them. When we add, we find 19x plus 0 equals 19. Dividing each side by 19, we find x equals 1. So now we have our x value. We still need to find y, so in step 2, we're going to solve for the eliminated variable, y, and use either one of the original equations. In this case, we'll use the second equation, 7x minus 5y equals 17. So 7 times 1, our value of x that we found is the solution, minus 5y equals 17. So y equals negative 2. Our solution, therefore, is 1, negative 2. Your turn. Part A. How can you use the multiplication property of equality to change an equation in this system in order to solve it using elimination? Part B. Write and solve a revised system. And part C, show that the solution of the revised system is a solution of the original system.